Good afternoon. I recognize that I'm recording this ahead of time, but assuming that everything has gone to plan today, we've heard some amazing talks. My colleagues have showed us how climate change is impacting the Southwest US and what projections are showing us for the future, as well as how sensitive Colorado River runoff is to warming. They've discussed climate adaptation strategies and freshwater ecosystems, and how we can use climate projections and other data and tools to aid in resilience planning. And we've also learned about a specific case study on the Escalante River watershed. And so I'm going to attempt to bring it all home with next steps and specifics for how stream practitioners can find climate data and information to assist in developing an effective climate adapted response. So first, I'd like to acknowledge that the information I'll be presenting mostly comes from this recently published guidebook, which has likely already been mentioned today. The book is about designing and implementing stream restoration in the Southwest US, Northern Mexico, and Australia, and it includes chapters ranging from planning and implementing your stream restoration project to all the way to monitoring. I was involved in the chapter on adapting your stream restoration project to climate change, along with the other authors that you see listed here. One section of this chapter is dedicated to highlighting and describing sources of climate data, predictions, and climate projections that stream practitioners can use to adapt their restoration project to climate change. And these sources of information are what I'll be highlighting today. So climate services is an umbrella term that really refers to any group that is involved in gathering, analyzing, and distributing climatic data, projections, or information to the public. Data they tend to provide to end users can include weather station data, seasonal predictions, and long-term climate projections. And they can also help restoration teams in a variety of ways, including assisting with, sorry about my dog, including assisting with the collection, analysis, and interpretation of climate data and securing additional resources to address gaps in knowledge. And in the past decade or so, the number of climate service providers has really skyrocketed. So in the US, for example, some examples include the National Oceanic and Atmospheric Administration, the Regional Integrated Sciences and Assessments Program. So those are referred to as the NOAA RISAs. The USDA Climate Hubs, the National Integrated Drought Information System, or NIDIS, the Regional Climate Centers, and the USGS Climate Adaptation Science Centers, or CASCs, of which I am a part. In Mexico, the Mexican Institute of Water Technology and the National Institute of Ecology and Climate Change can be considered climate service providers. And each provider fills a unique niche, and they tend to work closely together to leverage each other's strengths. So the Climate Adaptation Science Centers are a good example of a climate service provider. They work mostly with natural and cultural resource managers and are focused on co-produced research, or research that is conducted with managers to ensure that their research results in tools, techniques, models, and actionable information to facilitate robust decision-making by resource managers. And so there are 8. We just added a Midwest center, so my apologies. There are 9 centers across the country, and all are under the Department of the Interior and managed by the USGS National Climate Adaptation Science Center. They provide funding opportunities, trainings, and workshops for natural resource managers and researchers in the region, as well as dissemination of relevant research through webinars, podcasts, fact sheets, and other outreach materials. So I am the Science Communications Coordinator for the Southwest CASC, which is one of these regional centers. Like the other centers, we are a collaborative federal university partnership between the USGS and 7 academic institutions from across the US Southwest. So you can see in the orange map there. So the mission of the Southwest CASC is to work with natural and cultural resource managers to develop and deliver scientific information and techniques to anticipate, monitor, and adapt to climate change in the southwestern United States. So another climate service provider that fills a different niche are the USDA climate hubs. While the CASCs mostly work with natural resource managers, the climate hubs were established to deliver science-based knowledge, practical information, and program support to farmers, ranchers, and forest landowners. So a different group of stakeholders. And in partnership with various entities such as universities and farm groups, they provide tools, strategies, management options, and technical support to help land managers adapt to climate change. So in our region, the Southwest Hub, the Southern Plains Hub, and the California Hub, they all serve the US-Mexico border region. And their websites link to regional tools, data, and other educational materials. A particularly useful tool is the Climate Hub's Toolshed, which is a database of tools that are relevant to climate variability and change, as well as other factors such as drought, pests, and extreme weather. I mentioned the NOAA RISA. So the NOAA RISA teams work in sustained partnership with local decision makers to help stakeholders understand and adapt to regional climate impacts. And so the types of products and management efforts undertaken by the RISAs vary widely, but they share the common feature of emerging from real world challenges faced by stakeholders. The RISA teams that serve the Southwest are the California Nevada Applications Program, or CNAP, the Climate Assessment for the Southwest, or CLIMAS, the Southern Climate Impacts Program, or SCIP, and the Western Water Assessment. You can tell how much climate service providers like our acronyms. So some of the services that they provide include various tools, seasonal predictions and outlooks, and climate data. And one example is the Intermountain West Climate Dashboard that provides seasonal outlooks and temperature, seasonal outlooks of temperature, precipitation, and snowpack for Western states, drought monitoring, current and forecasted stream flow, and also reservoir storage data. The tree flow database is another example, and this database provides stream flow reconstructions, data access, and examples of the ways in which water managers are using stream flow reconstructions. And then lastly, I just wanted to mention that CLIMAS provides a monthly climate outlook for their region, which is Arizona and New Mexico. And this outlook recaps weather over the past few months and also shows the outlook for the upcoming months. So those are just like some examples of what the NOAA RISAs provide. And then lots of federal government agencies, in addition to hosting climate service organizations like the ones I've just described, they also provide other resources on climate change. So example, the USGS has a national climate change viewer that displays climate projections for various parameters, including temperature, precipitation, and runoff over the next 100 years, viewed by state or watershed. Users can choose the time period they're interested in and which model and future scenario they would like to view. So if you go to the website right now, it explains that they're currently working on a revision of this viewer, but it should be coming out soon. The Bureau of Reclamation has a climate change page with risk assessments and other reports, a Water Smart page with basin studies and river basin assessments, and a tool that provides data and maps for viewing climate and hydrology projections in US river basins. And there are also several nonprofit organizations that provide tools and resources related to climate information. And perhaps the most well-known is the Climate Adaptation Knowledge Exchange, or CAKE, which is founded and managed by EcoAdapt. The interactive online database, it provides information via a virtual library, directory of practitioners to share knowledge and data tools and information from other sites. And then another nonprofit I wanted to mention is the Conservation Biology Institute, which, among other things, they provide a mapping and analysis platform called Databasin that allows users to explore over 2,000 data sets, create custom visualizations, and publish data sets and maps. And then lastly, I just wanted to talk about the universities and state climate offices. So universities are often a trusted source of climate information as well. They may host useful tools, such as this one here, Drought View by the University of Arizona. And Drought View allows the user to visualize drought parameters, including vegetation and precipitation indices. And then another example is this digital climate atlas for Mexico. And this is from the National Autonomous University of Mexico, and it allows visualization of past and future climate data for the country. And so the researchers at universities themselves are also a great resource too, as they're often willing to collaborate with practitioners on issues of mutual interest. And then state climate offices. So there's a state climate office in each state, with a state climatologist appointed by the state to be a source of statewide climate information to support researchers, stakeholders, and the general public. And so the climate office is usually based at a local university. State climatologists work closely with other climate service organizations. They regularly give presentations and respond to inquiries. And then the state climate office websites also provide weather and climate information and links to other resources, including climate data and seasonal outlooks. Okay, so I just went through a whole bunch of climate service providers. And of course, you guys remember all of the ones I just mentioned, right? Just kidding. So luckily, some other people recognized how many climate service providers there are. So the organizations that I've listed here, they realized that there are so many climate service providers out there. It was really getting hard to keep track of them all. And, how is someone supposed to be able to find the provider that will help them get the information that they need? And so these organizations created a database to make it easy to find service providers. So the user can search by state, sector, timescale, types of service provided, and other parameters to figure out which provider they should contact for help. So this would be a good first place to go when you're starting out looking for help. So I wanted to mention a couple other tools. I mentioned some already, but I would be remiss if I didn't mention a couple more. So the U.S. Climate Resilience Toolkit, it's really a one-stop shop for climate adaptation tools, case studies of climate resilience, reports and state climate summaries, training courses, and help in finding service providers as well. And probably the most popular tool it provides is the Climate Explorer, which allows the user to graph and map historical and projected climate data for any county in the US. And then another tool worth mentioning is the Climate Toolbox, which again houses many tools helpful for planning for climate change impacts. And so there are tools for mapping historical and future climate, graphing future stream flow, mapping future hardiness and crop suitability zones, and also graphing seasonal forecasts for a given location, plus many more. And then lastly, I just wanted to mention assessment. So in addition to all of the climate services available, there are also a myriad of climate assessments that can prove useful in planning by providing past, present, and future climate information for your region of interest. So there are national assessments, such as the U.S. National Climate Assessment that's updated every 4 years, and many other countries have their own national assessment reports as well. There are regional assessments, such as the Assessment of Climate Change in the Southwest U.S., published in 2013, and a global assessment run by the Intergovernmental Panel on Climate Change, or the IPCC, which is updated every 7 years. And so the next IPCC report, the 6th assessment report, will be published later this year. So trying to tie this all together, I wanted to take a quick look back at the Escalante River example that we were introduced to earlier this afternoon. So using some of the services and the tools that I've mentioned, in this presentation, I've gathered some weather and climate information that might be useful in adapting this project in anticipation of future climate change. So using the Climate Explorer tool, I've mapped here temperature from 2017 to present, and also precipitation over the same time period. And this is from the Grand Staircase Escalante National Monument Weather Station. And then next, using the same, pretty much the same variables looking to the future. So I used Climate Explorer again. And so the top graph shows the projected average daily max temperature. And then the bottom graph shows the projected total precipitation. And these are for Kane County, Utah through 2050. And so it looks like precipitation is unlikely to change much. And this is common throughout the Southwest for the future, but max temperature will likely increase by about 4 degrees Fahrenheit by 2050. And so the temperature alone will increase evapotranspiration and dry out soils, even if there's little to no change in precipitation. So next I wanted to look at stream flow. And so I used the tree flow tool to plot this is the 10-year running mean of reconstructed Colorado River flow. This is at Lee's Ferry from the years 1490 to 1997. And so the reconstructed values here are shown in blue in this graph, and observed values are shown in gray. And the long-term reconstructed mean is that dashed gray line across the middle. And so this data can give us an idea of what stream flow has looked like in the past at this site at Lee's Ferry. And then taking it to look to the future for stream flow, I used the Climate Toolbox tool to plot projected stream flow at Lee's Ferry, so the same site, for the years 2040 to 2069. And so the black line here shows the historical values, and then the orange and the blue lines show 2 different future scenarios. And so we can see that the peak in stream flow is projected to occur about 1 month earlier, now in April to May instead of the June to July range. And this is based on either future scenario. And then percentage-wise, breaking this up by percent, this means that we could expect much higher than normal stream flow in April compared to historical records, but much lower than normal stream flow during the summer months. So wrapping this all up, some big takeaways. So as you can see, there are tens, if not hundreds of tools, assessments, and other climate services that are available to help practitioners when planning for climate change. Climate service organizations are a great resource to turn to, and they offer many different resources, including funding opportunities and expertise. And really don't be afraid to reach out. It's our job as climate service providers to really help in any way that we can. So, thank you.